Yes, in this video, I'm going to discuss about focal power of a converging lens and a diverging lens. Okay, so look at the diagram here. The first one is a concave lens. And here, the first diagram, look at here, we have a parallel beam of incident light. So these are the parallel beam of incident light, right? So after the refraction, the refracted rays are diverging like this, isn't it? But if we draw an imaginary lines in backward direction, these imaginary lines coincide exactly on the principal axis at focus. Correct or not? Similarly, in second diagram also, after the refraction, the refracted rays are diverging like this, but the imaginary lines of refracted rays are converging at this location. That is nothing but focus. Similarly, in third case also, this will be the focus. Correct or not? So this will be the focus. Look at the three diagrams here, 1, 2 and 3. Which diagram having maximum focal length? Third diagram only, no, because after the refraction the refracted rays are meeting at this location as compared to the first diagram, second diagram and third diagram. So for third diagram only the focal length value is maximum, isn't it? And also, according to new Cartesian sign conventions, here the focal length values are forming left hand side. That means the distance towards left side is negative, right? According to new Cartesian sign convention, the distance towards left side is negative. Okay, just a second, I will erase all this because I'm going to mention values here. Okay, right, thank you. Let us assume for first case, this is the focus, right? So from here to here, I'm assuming 10 centimeter. 10 centimeter. Okay. And for second diagram, the focal length value I'm assuming here, that is 20 centimeter. Okay. And for third diagram, the focal length is maximum value. Let us assume here I'm assuming 30 centimeter. Okay, but according to new Cartesian sign convention, these focal lengths are left hand side only, so that's why negative. So that's why minus 10 centimeter, minus 20 centimeter and minus 30 centimeter. Okay, now coming to the convex lens. Okay, so look at the first diagram here. We have a incident parallel beam of light. So after striking the convex lens, the refraction will take place. All the refracted rays are meeting on the principal axis at this location, isn't it? Similarly, look at the second diagram here. We have a parallel beam of incident light. After refraction, all the refracted rays are converging at this location, isn't it? Similarly, in third case also, we have a parallel beam of incident light. So here, after the refraction, the refracted rays are converging at this location. Okay, so look at these three diagrams carefully. For which diagram the focal length is maximum here also? For third diagram, focal length value is maximum as compared to 1 and 2. Correct or not? So here also I am assuming the focal length value is 10 centimeter for first diagram, and for second diagram I am assuming 20 centimeter, and for third diagram I am assuming 30 centimeter. Okay, but these focal lengths are positive. Why? Because after the refraction, the refracted rays are converging on the principal axis right hand side. So according to new Cartesian sign convention, distance towards right side is positive. Okay, and look at this picture carefully. For focal power, I mentioned formula, power is equal to 1 by F. So I'm going to use this formula for all these three different cases for concave lens as well as convex lens. Okay, so for concave lens, for first diagram, so here I'm writing, one second. Yes, thank you. So power F is equal to 1 by F. Correct or not? So for first diagram, what is the focal length value? Minus 10 centimeter. So just convert the 10 centimeter into meters, you will get 1 by 0.1 meter. That is negative, no, so 1 by minus 0.1 meter. So if you're simplifying this, you will get minus 10 diopter. So diopter is the SI unit of power. I mentioned at the bottom of the page. Look at here. Okay. And now coming to the second diagram of concave lens. So again I'm writing power is equal to a reciprocal of focal length. Okay. So power is equal to 1 by 20 centimeter. I'm going to convert into meters. So we can write it as 0.2 meter, but the value is negative, no. So that's why minus 0.2 meter. So 1 by 0.2 means you will get minus 5 diopter. Okay. Now coming to the third diagram. Again I am writing power is equal to a reciprocal of focal length. But according to this diagram, the focal length value is 30 centimeter. That means minus 30 centimeters. I'm going to convert that minus 30 centimeter into meters. So we can write it as 1 by minus 0.3 meter. Okay. So 1 by 0.3 means that is nothing but you will get a 3.33. But negative, no. So minus 3.33 diopter. Okay, so this is for negative powers. Now let's coming to the positive side, that means convex lens case. So again I'm writing power P is equal to 1 by F. So 1 by, here focal length value how much? 10 centimeter. If you are converting this 10 centimeter into meters means you will get 0.1 meter. So 1 by 0.1 means you will get 10 diopter. Now coming to the second diagram, power is equal to 1 by focal length. Here focal length value is 20 centimeter. You just convert into meters. 1 by 0.2 meter. So 1 by 0.2 means you will get 5 diopter. Okay. Now coming to the third diagram, power is equal to 1 by focal length. Here focal length value how much? 30 centimeter. You just convert that 30 centimeter into meters. So you will get power is equal to 1 by 0.3 meter. 1 by 0.3 means if you're simplifying, you will get 3.33 diopter. Okay, now look at this picture carefully. For concave lens, for first value we got minus 10 diopter, but for convex lens we got plus 10 diopter, isn't it? Similarly, for concave lens, second power value we got minus 5 diopter, but for convex lens we got plus 5 diopter. And similarly in third diagram, for concave lens power value is minus 3.33 diopter, but for convex lens we got plus 3.33 diopter. So that means by seeing these values and pictures as well as the new Cartesian sign conventions, we can understand one point here, that is for concave lens power value always negative. So here also we got negative value. Here also we got negative value. But for convex lens, the power values we got positive. Positive 10 diopter, positive 5 diopter, positive 3.3 diopter. So please remember the point. For concave lens, power always negative. For convex lens, power always positive. What is the meaning of focal power? A simple definition of focal power is the reciprocal of focal length. Reciprocal of focal length is nothing but inversely proportional to focal length. Okay, so the SI unit of power is diopter. So here I mentioned. Okay, so I hope you understand. Thank you.